Welcome, geography enthusiasts, to a thrilling journey through the world of geomorphology. Imagine this: the earth beneath our feet, the mountains that tower above us, the rivers that flow through our lands. They all tell a story of processes, forces, and time. That's what geomorphology is all about. It's the scientific study of the origin and evolution of our planet's landforms. It's through this lens we'll be exploring everything from the factors controlling landform development to the dynamic movements of the Earth's crust. We'll delve into the mysteries of geosynclines, continental drift, and plate tectonics. We'll examine the power and impact of volcanicity, earthquakes, and tsunamis. And we'll journey through the cycles that shape our landscapes and the practical applications of geomorphology in our daily lives. So, are you ready for the ride? Fasten your seatbelts as we delve into the fascinating world of geomorphology. Let's dive into the factors that shape our Earth's landforms. A fascinating world of forces is continuously at work, carving and crafting the landscapes we see around us. Imagine them as master sculptors, working tirelessly, shaping our world with every passing second. First off, we have endogenetic forces. These are internal forces originating from deep within the Earth. They're responsible for raising mountains, causing earthquakes, and creating volcanoes. Think of them as the Earth's inner artists, bringing new forms and shapes to life. On the flip side, we have exogenetic forces, the external sculptors. These forces include weathering, erosion, and deposition, which work on the Earth's surface. They're like the finishing touch, smoothing rough edges, filling in gaps, and polishing the Earth's surface to its present state. Together, these internal and external forces shape and reshape the landscapes, mountains, valleys, and plains we live in. These forces are the unseen hands, shaping the Earth as we see it. Ever wondered how the Earth's crust came to be? Let's dive into this fascinating journey of our planet's formation and evolution. It all started around 4.5 billion years ago, when a giant cloud of dust and gas collapsed under its own gravity, forming our solar system. The Earth, initially a molten mass, began to cool, and the outer layer solidified to form a thin crust. This crust wasn't fixed though, it was constantly changing and evolving. Volcanic activity brought molten rock, or magma, to the surface, creating new crust. Meanwhile, weathering and erosion wore away existing landforms, recycling the crust back into the mantle. Over millions of years, this process of creation and destruction has sculpted the Earth's crust into the diverse landscapes we see today. So, from a whirlwind of cosmic dust to the solid ground beneath our feet, the Earth's crust has undergone an incredible journey. And that, my friends, is how our Earth was born and evolved. Before we dive into the details of geosynclines, continental drift, and plate tectonics, let's take a moment to explore another significant aspect of our planet: geomagnetism and the physical conditions of the Earth's interior. Did you know that our Earth behaves like a giant magnet? That's right, and this is what we call geomagnetism. The Earth's magnetic field extends from the inner core out into space where it meets the solar wind, a stream of charged particles emanating from the sun. This magnetic field is vital. It shields our planet from harmful solar radiation, guides animal migration, and is the reason compasses point north. But how is it generated? It's all thanks to the churning and convecting liquid iron in the Earth's outer core, a process known as the geodynamo. Now let's delve deeper into the Earth's interior. You've probably seen diagrams of the Earth sliced in half, revealing several layers. From the outermost crust we move to the mantle, then the outer core, and finally the inner core. Each of these layers has different physical conditions, from temperature and pressure to composition. The crust where we live is relatively cool and rigid. Beneath it, the mantle is hotter and capable of slow, flowing movements. This heat comes from the decay of radioactive elements and the residual heat from when the planet formed. The outer core, even hotter and under greater pressure, is mostly composed of liquid iron and nickel. This is where our planet's magnetic field gets generated. Finally, the inner core is a solid ball of iron and nickel, with temperatures as hot as the sun's surface, and under immense pressure. So, from the magnetic field that protects our planet to the intense heat and pressure of the Earth's core, we've explored some of the fundamental aspects shaping our world. And with that, we're ready to move on to geosynclines, continental drift, and plate tectonics. Now let's shift gears and discuss some heavy hitters: geosynclines, continental drift, plate tectonics, and isostasy. First up, geosynclines. Picture this: a vast, elongated trough or basin in the Earth's crust. This isn't just your everyday pothole, though. We're talking about colossal depressions that accumulate sediment over millions of years. But it doesn't stop there. As these geosynclines fill up, they begin to fold and crumple under the immense stress, forming mountain ranges. So, the next time you're hiking up a mountain, remember it might just be a crumpled up geosyncline. Next on the itinerary is continental drift. This is the theory that the Earth's continents have moved over geologic time relative to each other. Picture yourself on a slow-moving conveyor belt, but instead of checking out at the grocery store, you're on a continent drifting across the Earth's surface. Alfred Wegener, the father of this theory, proposed this idea back in the early 20th century. He observed that continents seemed to fit together like pieces of a jigsaw puzzle, suggesting they were once a single landmass. This supercontinent, known as Pangaea, eventually split and drifted apart to form the continents as we know them today. At the third stop we have plate tectonics, the theory that the Earth's outer shell is divided into several plates that glide over the mantle. Imagine the Earth like an orange, with the peel representing these tectonic plates. These plates are constantly moving, albeit at a snail's pace, colliding and diverging, causing earthquakes, forming mountain ranges, and creating volcanic activity. It's a slow dance of epic geological proportions happening right beneath our feet. Now, let's introduce isostasy. This is the balance or equilibrium in the Earth's crust maintained by the buoyancy of lithosphere floating on the denser, semi-fluid asthenosphere below. Imagine a ship perfectly balanced on the sea, neither sinking nor rising. That's the Earth's crust for you, gracefully balanced on denser layer beneath. And there you have it. From the deep troughs of geosynclines through the wandering continents, the graceful dance of tectonic plates, to the perfect balance of isostasy, we've journeyed through the dynamic and ever-changing face of our planet. With that, we've untangled some of the most complex processes shaping our Earth. Before we launch into the seething world of volcanicity, earthquakes, and tsunamis, let's consider a relatively recent geological concept: mountain building. This process, known as orogeny, is believed to be another significant player in geomorphological processes. Born from the convergent tectonic activity, when two plates collide, mountains rise as a testament to the immense forces beneath our feet. Now brace yourself as we venture into the fiery and tumultuous world of volcanicity, earthquakes, and tsunamis. Hot magma, shaking ground, and towering waves, these might sound like the makings of a blockbuster disaster movie, but they're actually part and parcel of our planet's natural processes. Let's start with volcanicity, the process that gives birth to volcanoes. When the Earth's tectonic plates move and collide, they create pressure deep within the Earth's mantle. This pressure forces molten rock, or magma, to the surface, resulting in a volcanic eruption. The effects can be devastating, but they also create fertile soil that aids in plant growth and ecosystem diversity. Next on the docket we have earthquakes. Just like volcanicity, earthquakes are a result of tectonic activity. When these massive plates grind against each other, they sometimes get stuck at their edges due to friction. Over time, stress builds up until it's released in a sudden jolt, causing the ground to shake. That's an earthquake for you. These seismic events can be incredibly destructive, leveling cities and causing loss of life. But they also serve as a potent reminder of our planet's ever-changing nature. Lastly, we dive into the realm of tsunamis. Imagine an earthquake occurring under the ocean floor. The sudden shift of tectonic plates can displace huge volumes of water, sending powerful waves racing towards the shore. Tsunamis can be catastrophic, engulfing coastal areas and causing widespread damage, yet they too play a role in shaping our coastal landscapes and ecosystems. So, volcanicity, earthquakes, tsunamis, and mountain building, they might be formidable forces of nature, but they're also essential players in the grand scheme of geomorphology. They shape our landscapes, influence ecosystems, and continually remind us of our planet's dynamic and ever-changing character. These dramatic events remind us of the dynamic nature of our planet. From fiery volcanic eruptions to tranquil and serene landscapes, let's delve into the intriguing world of geomorphic cycles and their role in shaping the world around us. Geomorphic cycles, often referred to as cycles of erosion, are the integral processes that form and transform the landscapes we see every day. The cycles commence with uplift, a fascinating process where tectonic forces push land upwards, creating a fresh landform that's a blank canvas for erosion to work its magic. In terms of denudation chronology, this is the initial stage where the land exposes itself to natural forces, setting the stage for other processes like erosion, transportation, and deposition. Erosion, the star of the cycle, comes in an array of forms including water, wind, and even glaciers. It masterfully sculpts mountains into valleys, carves out river channels, and smooths out rough edges. Channel morphology, or the study of the characteristics, arrangement, and dimensions of river channels, is a significant aspect of this process. Over millions of years, these channels evolve, leaving behind evidence of their journey, submerged beneath layers of sediment. As these processes repeat over millions of years, they give birth to the diverse landscapes we see today. Weathering plays a vital supporting role in this cycle. It is the process of breaking down rocks and preparing the stage for erosion by gradually weakening the rocks. Then comes surface erosion, a process that creates erosion surfaces, gently leveling out the landscapes, creating mesas and plateaus. This process is necessary for slope development, which refers to the gradient of the land. Steeper slopes tend to experience more rapid erosion, while gentle slopes are sculpted more slowly. Finally, the process ends with deposition, where the eroded material is laid down to form new landforms, like deltas and beaches. This process continues, creating a never-ending cycle of creation and transformation, a geological masterpiece. So the next time you find yourself admiring a serene landscape or standing atop a mountain peak, remember these intricate geomorphic cycles that tirelessly work behind the scenes to make it possible. Have you ever wondered, what have we really learned, and how can we practically implement this knowledge? Let's delve deeper. Geomorphology, a scientific field that explores the understanding of the Earth's physical features and processes, emerges as an indispensable tool in both economic geology and environmental studies. It provides insights into the planet's past, present, and possible future geological settings. Now, shifting the focus to economic geology, it's like unraveling a complex treasure map guiding us to invaluable mineral deposits. Economic geology deals with materials that fuel our economy, such as fuels, metals, and non-metallic minerals, among other Earth resources. By meticulously studying the Earth's structures and landforms, geologists can predict the potential of these obscured resources. Geomorphology lends a helping hand in this quest, by offering a broader understanding of the Earth's mantle, leading to more precise predictions. Moving to environmental studies, where geomorphology plays a more than crucial role. It helps in understanding and managing natural hazards like landslides and floods, through the study of the Earth's surface evolution over time. It allows scientists to predict these disastrous events and create effective precautionary measures. Moreover, geomorphology is an unsung hero in land use planning. It aids in deciphering the physical characteristics of a region, which, in turn, assists us in making informed decisions about where to erect infrastructure, manage water resources, and even how to conserve biodiversity in the most effective way. Hence, as we can see, geomorphology isn't just academic or theoretical, it's a practical with real-world applications that touch various aspects of our lives. It's the silent worker, shaping our understanding of the Earth and helping us harness its resources more efficiently. We've journeyed through the fascinating world of geomorphology, but our exploration doesn't have to end here. We've traversed the contours of landform development, delved into the origins and evolution of Earth's crust, and navigated the shifts of continental drift and plate tectonics. We've felt the heat of volcanicity, the shake of earthquakes, and the surge of tsunamis. We've cycled through geomorphic cycles and watched landscapes develop before our eyes. We've seen the practical applications of geomorphology and its impact on our environment and economy. But remember, this is just the tip of the iceberg. There's a whole world beneath the surface waiting for you to uncover. So why not delve deeper into the books, research papers, and documentaries on geomorphology? The more you learn, the more you'll realize that our planet is a marvel of continuous change and evolution. If you enjoyed this journey, don't forget to subscribe and like the video to join us on future adventures. Until then, keep exploring.